Next, we're going to take a look at some specific functions and compute their derivatives using the 5 basic derivative rules plus. Before you watch this video, make sure you first try to compute these derivatives on your own. So make sure to look at the table from the previous video with the 5 basic derivatives plus and try to apply that table to these functions to get practice taking these derivatives, and then you can watch the video and compare your answers with the answers on the video. So the first function is y is equal to 3x squared plus sine of x raised to the power 7. So the rule that we want to use is the first rule. So rule number 1 says that d by dx of u of x to the n is equal to n times u of x to the n minus 1 and then times u prime of x. So here our u of x is going to be the inside function 3x squared plus sine of x. So this is called the inside, right? So it's basically, you can think of this as u of x to the power 7, right? So the u of x is identified with 3x squared plus sine of x. So when we take the derivative, well, the 7 comes down out front, and then you subtract 1. So we basically just get 7 u of x to the 6th, and then times the derivative of the inside. So this is the step that I usually, do mentally. So this is, in your head. Right? So when I look at this complicated one, I see, the only thing I see here is just u of x. It's just one piece. It's something to the 7th power. Something to the 7th. The 7 comes down, so it's 7 something to the 6th. Just like if you have u of x to the 7, the 7 comes down, it's 7 u of x to the 6th, and then times the derivative of the inside. So let's actually compute this now. So dy dx, so the 7 falls out front, so we have 7, and I just recopy everything inside, 3x squared plus sine of x. And then I subtract 1 from the 7, so it's 7 times 3x squared plus sine of x to the 6th, and then times the derivative of the inside function. So the derivative of the inside, 3x squared, the 2 comes down, and it's 2 times 3 is 6, it's 6x. And then the derivative of sine is cosine, so 6x plus cosine of x. So that is the derivative of our function. So 3x squared plus sine of x all to the power 7th. 7 comes down, we get 7 times 3x squared plus sine of x to the 6th, and then times 6x plus cosine of x. So pretty, amazing, because this is, how would you just be able to guess this? This is fairly complicated. You have something to the 7th power, and yet with relative ease, boom, there it is. Let's look at our next example. So this one we have sine, so y is equal to the sine of 3x squared plus 4. Okay, well again, the inside function is this stuff right here. So we're into rule number 2 now. Rule number 2 says that the derivative of sine of u of x is just cosine of u of x, and then times u prime of x. Okay, so basically, when we look at this, we just see sine of u of x, where the inside function, 3x squared plus 4, is our u of x. So when we take the derivative, sine turns into a cosine, and then the inside stays the same, 3x squared plus 4, but then we multiply by the derivative of the inside. So the derivative of 3x squared is 6x. The derivative of 4 is 0, so we just get times 6x. Then we might want to rewrite this, 6x cosine 3x squared plus 4. And so there's the derivative of our function. Okay, our third example, we have the function sine of x. So this is actually very similar. It's the exact same rule that we used before. The derivative of sine of u of x is cosine of u of x times u prime of x. In this case, it's sine of x that's our inside function u of x. So when we take the derivative, we get dy dx. It's sine of something, right? I don't care what is in here yet. So it's just sine of something. The derivative is going to be cosine of something. So it's going to be the cosine of sine of x. And then when we've got that down, we go back and look at that something. We look at the u of x and multiply by its derivative. Well, the derivative of sine is cosine, so it's going to be times cosine of x, just like that. So the derivative of sine of x is cosine of sine of x times cosine of x. So this cosine of x is the derivative of the inside. So I took the inside, took the derivative, and multiplied it out there. So this cosine of x is coming directly from the inside function. Example number 4, we have the ln of sine of x. Okay, now we're into rule number 5. So rule number 5 says that the derivative of ln of u of x is equal to u prime of x over u of x. So recall that the derivative of ln of x by itself is just 1 over x. So the derivative of ln of x was just the function 1 over x. So when we have ln of u of x, it's still 1 over u of x, and then we multiply by u prime of x, or we can just do it all as a single fraction. The derivative of ln of u of x is u prime of x over u of x. So when we have here, again, we first want to identify, okay, this is the inside function. So this is the guy who plays the role of u of x. So it's ln of something. So the derivative, dy dx, is going to be the derivative of that something divided by the original something. So the derivative of sine is cosine, and then divided by just the something. So this is the derivative, so this is our u prime of x, and then this is the original inside function u. So it's just the derivative of the inside divided by the original inside. So cosine of x over sine of x, and that is also equal to cotangent of x. So the derivative of ln of sine of x is just cotangent of x, just like that. Our next one, we have y is equal to e to the sine of x. Now this is rule number 4, and rule number 4 was the derivative of e to the u of x is equal to, you rewrite it, and then just multiply it by the derivative of the exponent. So you multiply by u prime of x. So again, the inside function is this guy up here. So we just see it as e to something, e to bubble, right? And when we take the derivative, we just rewrite it. The derivative of e to the bubble is e to the bubble. Right? The derivative with respect to bubble, v to the bubble, e to the bubble, and then you multiply it by the derivative of bubble. So the derivative of sine is cosine of x. So the derivative of e to the sine x is e to the sine x times cosine of x. Right. The next one we have a little bit different. Y is equal to cosine of e to the x. So this is rule number 3, which says that the derivative of cosine of u of x is negative sine of u of x, and then times u prime of x. Just like that. Okay. So the inside function now is e to the x. So it's cosine of something, right? The outer function is cosine, and the inner function is e to the x. So dy dx, the derivative of cosine is just minus sine. Then we keep the inside the same. And then when we're done, we multiply by the derivative of e to the x. Now the derivative of e to the x is just e to the x. And there you go. The derivative of cosine of e to the x is minus sine of e to the x times e to the x. It's that simple. So you just practice these over and over again, practice as many as you can until you get the feel. And then when you see a function like this, you'll never forget these rules. When you see a function, boom, you'll be able to take the derivative like lightning. Example number 7, we have y is equal to the square root of sine of x plus cosine of x. Now this goes back to rule number 1. So rule number 1 was when you have u of x to the n, right? So this time n is 1/2. So the inside is sine of x plus cosine of x. So it's basically just the square root of some u of x. So we identify sine of x plus cosine of x with u of x. We have the square root of u of x, or u of x to the 1/2. Now, the square root of something, again, it's something to the 1/2. 1/2 comes out front, and then you get 1/2 times that thing to the minus 1/2. So the derivative, we get the 1/2, and then u to the minus 1/2 is divided by square root of u. Right? The 1/2 makes it the square root, the minus in the exponent makes the reciprocal, so it's in the denominator instead of the numerator. So the derivative of square root of x is 1 over 2 root x. Derivative of square root of u is 1 over 2 square root of u. But then we have to multiply by u prime of x, so then we multiply it by u prime of x. So for this one, dy dx, so it's something to the 1/2. The 1/2 comes down, so it's 1/2 something to the minus 1/2. When you have something to the minus 1/2, that's the square root, and it's in the denominator, sine of x plus cosine of x. Almost done. Now we have to multiply by the derivative of the inside. So the derivative of the inside, we have 2 terms, so we just do each term individually. Derivative of sine is cosine, and the derivative of cosine is minus sine. So this part up here is the derivative of the inside, right? So the derivative of sine of x plus cosine of x, the derivative of sine is cosine, derivative of cosine is minus sine, so I'm just multiplying by the derivative of the inside. Next example, we have y is equal to sine squared of x. And this is the same rule. It's still rule number 1, right? So we basically have u of x squared. So in this case, sine of x, so the inside function, u of x is just sine of x because we have sine of x squared. So basically, when we have this, it's the same as saying sine of x squared like that. A lot of people, it throws them off because they think, well, how do you do sine squared of x? But it's just that same rule number 1. The 2 comes out front, so the derivative, dy dx, 2 comes out front, and then you rewrite the inside function. So it's 2 sine of x, and then you multiply by the derivative of the inside. So we have to multiply by the derivative of sine, which is cosine of x. So it's 2 sine of x cosine of x. And as an added bonus, so this is my bonus, let's compute the derivative of sine squared x plus cosine squared x. And what we'll do is we'll prove that this is equal to 1. So we'll prove the trigonometric identity that sine squared x plus cosine squared x is equal to 1 using calculus and derivatives. So the first step is to prove that this is constant. And then we'll say, well, you can just evaluate it at any point and you get 1. So dy dx, so we just did this one. So it's sine of x quantity squared, so the 2 comes out front. So we end up with 2 sine of x, and then times the derivative of sine of x, which is cosine of x. Okay, so that's the first term. So this goes here. So then the derivative of cosine squared x, so we do plus, it's the same deal. So the 2 comes out front. And I wouldn't normally draw these circles like this. I'm just showing you what's in my head. The 2 falls down out front. So we have 2, then the inside was cosine of x, and then we multiply by the derivative of the inside, which is negative sine. Now a lot of students will write it like this. Technically it's correct because it's this times negative sine, but it's just, stylistically it can throw somebody off because it looks like cosine minus sine of x. It doesn't necessarily look like a product. So I always keep track of the plus and minus signs in my head and move them out front automatically. So we have the 2 comes down, so we have 2 cosine of x times the derivative of cosine of x, which is negative sine of x. So I'm going to put the sine of x here, and remember that I still have to multiply by a negative 1. So that negative sign just changes the sign. Instead of plus, this becomes minus. So I take care of the negative by writing minus instead. Now what do we have? We have 2 sine of x cosine of x minus 2 cosine of x sine of x. Well, this term is the same as that term, and we're subtracting them. So dy dx is just equal to 0. So the derivative is constant, which means it's a line, and it's a line with 0 slope. So it's a constant function. So whatever sine squared x plus cosine squared x is, it has to be a constant. And so we can evaluate it. So let's do f of 0. So let's say that this is f of x, sine squared x plus cosine squared x. F of 0 is sine squared of 0 plus cosine squared of 0. Now sine of 0 is 0, and cosine of 0 is 1. So initially the y value is 1, and since it's a constant function because it has 0 derivative, it has to equal 1 for all values of x. So we just proved the trigonometric identity that sine squared x plus cosine squared x is equal to 1 using calculus and the basic derivative rules.